Welcome to Cape Nature's Conservation Review, Session 6, in which I will introduce you to the very exciting BioSCape project and how it meshes with Cape Nature's research and monitoring. Cape Nature is legislatively required to be able to report on the state of biodiversity and its threats in the Western Cape Province. This is an extensive task, as threatened habitats include terrestrial, freshwater, estuarine, and nearshore marine environments. Remote sensing provides opportunities to inform Cape Nature about the state of the environment and the threats posed to it. This is especially valuable for fire and invasive alien species, which are key ecological drivers in the province. We already have some satellite-derived fire scars for our protected areas, but what is the indigenous biodiversity doing across the province, and what are invasive alien species doing? And more broadly at a landscape scale, remotely sensed land use change is very useful for planning and monitoring, if the temporal and spatial resolutions are fine enough. But dealing with this data is a challenging task in a regional conservation agency. These challenges range from acquiring the data in the first place to processing it into a usable form for end users. And the data itself can be technically challenging to interpret. For one, the variability, particularly in the fynbos biome, makes interpretation a tricky business. Another crucial aspect is being able to have up-to-date information when you need it, so that you do not base decisions on outdated information. To deal with this, a great deal of highly capable capacity and computing power is needed. Fortunately, there are solutions out there, and today I'll be talking about the very exciting BioSCape project that has just kicked off with NASA and a host of collaborators. So what is the BioSCape project? It is a NASA-led biodiversity survey of the Cape, by which we primarily mean the Western Cape. It is a multi-partner, multi-researcher project to examine the relationships between remote sensing information and on-the-ground environments and ecosystems. So why the Western Cape? Well, the Western Cape Province is where fynbos is, and fynbos is a globally renowned hotspot of biodiversity, so a very good place to trial this technology and push it to its limits. If it works in the fynbos, then it can work anywhere. There is also a good conservation community in the Western Cape Province. I'll unpack and explain these broad statements in the next few slides. Here we have a diagrammatic representation of the BioSCape project. In the top panel, we see the collection of remotely sensed data from jet aircraft and satellites, combining with in-field studies. In the middle panel, we use this information to gain a better understanding of biodiversity, both taxonomic and functional, and how this is related to the remotely sensed data. And we do all this to get to the bottom panel, where we hope to gain a better understanding of how to conserve nature and ecosystem functioning, which all people need. NASA plays a crucial role in this project, as it develops the instruments with which to observe environmental processes on Earth, amongst other planets, and to test them before putting them into orbit, literally. We are very lucky to have NASA come to test some cutting-edge imaging spectroscopy to provide hyperspectral data in combination with structural data. Here I'm going to give you a very brief introduction to hyperspectral data. Historically, all we had was single-band images, producing a grayscale image as shown on the left, which, although allowing great visualization of the entire planet, did not provide much more than that. Fortunately, this was replaced with multispectral sensors, which provide more information, including being able to produce natural color images, but even more importantly by extending our view into the near-infrared and infrared bands, which tells us a lot more, for example, about how vigorously plants grow. Now, with hyperspectral sensors, we have hundreds of bands, giving us a wide view of much of the electromagnetic spectrum. The image on the top right shows an image from a multispectral sensor, whilst the one below provides visualization of hyperspectral data, revealing the wealth of information in other wavelengths. The NASA aircraft will be equipped with several sensors to cover a very wide range of frequencies. The other type of remotely sensed data we are going to get is structural. This is achieved by LiDAR sensors, the light-based equivalent of radar. This technique measures the reflectance of many pulses of low-power laser, which allows creating of 3D surface maps, great for estimating things like biomass. But to properly assess biodiversity on the ground, good old field work is required, and there will be loads of vegetation plots sampled, DNA and eDNA samples taken, and we'll even be measuring acoustic biodiversity with remotely deployed ground devices called audiomoths. These different sets of data will be analyzed to establish levels of biodiversity in the field to compare to the spectral and structural diversity patterns we'll be getting from the skies and space. NASA and their collaborators have been at pains not to come into our country and do so-called parachute science and run away again without any involvement, collaboration, acknowledgement, and training of us locals. They will also be making all of the information they collect freely accessible. In fact, much of NASA's data is already freely and is easily available, and this is an amazing service that they provide. So where exactly will this project be taking place? Well, the flight paths are going to be chosen to represent the fynbos biome as well as possible within the constraints of the time that they have available. A key informant in the design of the flight paths is going to be the location of Cape Nature protected areas, and so we have been a key consideration for locating this work. There are many uses of the kinds of remotely sensed data that the BioSCape project will be recording. Firstly, there is ecosystem mapping. This kind of data is very useful for mapping things like groundwater dependent ecosystems and being able to delineate different ecosystems. Secondly, we hope that it will be able to help us with ecosystem health monitoring, which includes degradation, presence of invasive alien species, and the effects of fire. Thirdly, we hope it will give us a direct insight into biodiversity. And then, this technology is also capable of informing us about ecosystem functioning. These instruments can effectively see water, moisture, temperature gradients on the surface and in the atmosphere, which provides opportunity to measure things like evapotranspiration and many other ecosystem functions. One of the major advantages of remotely sensed information is the scale at which it can be obtained. With these technologies, information for large parts or the entire Earth can be obtained. And because the satellites keep spinning around, we get many repeat observations, which is the perfect basis for monitoring, and long-term monitoring at that. It also fits well with the extended freshwater terrestrial ecosystems observation network projects in the fynbos biome in the Greater Cape Town and Garden Route projects. And NASA and its collaborators are providing free training on the use and analysis of remote sense data. The main aim of the BioSCape project, which is also of primary interest to Cape Nature as a conservation agency, is to assess the relationships between remote sensed information and ground-based biodiversity and ecosystem function. If these relationships do prove useful, then we can assess ecosystem health and how it changes over time. In particular, there is a big focus on invasive alien species in BioSCape project, and if this works well, which we all expect it will, then there is much that can flow from planning to quantifying the impacts of invasive alien species and invasive alien species management. In other words, what works where, how well, and this could feed directly into an adaptive management framework. Cape Nature has an important role to play in making this project work. We have a beautiful suite of protected areas that represent the ecosystem types that are the primary focus of the BioSCape project. Here, Cape Nature will be facilitating ground-based work, providing historical data for context, and we have expertise in some of the techniques and can assist with training the artificial intelligence models. Yes, artificial intelligence is popping up everywhere and is very well suited to this kind of challenge where massive data sets are involved. In this slide and the next slide, I will list all the formal BioSCape projects and will draw attention to 1. A project specifically looking at the detection of invasive alien plant species, and 2 projects where Cape Nature will be directly involved in ground-based monitoring and facilitating this research. And 3, an example of a project that is not terrestrially focused but concentrates on coastal environments. But BioSCape is a once-off project, so what happens after the jets go home, after having flown with their state-of-the-art sensors? This is where space comes back into the picture, as it is the aim of the project to get this kind of sensing technology up onto satellites. There are already a couple of hyperspectral sensors on satellites, but they have limitations and will not be as good as the new sensors that NASA has just developed. In fact, the BioSCape project will directly inform the satellite deployment and development of this technology in the future. Also, we are hoping that this project will initiate and lead to the development of data and application pipelines to regularly deliver highly informative products. If you'd like to know more about the project and track its progress, please do visit the website www.bioscape.io. I hope I've given you a reasonable understanding of what the BioSCape project does and how it uses airborne and spaceborne information to help us understand what happens back here on Earth. Thank you.